Okay, guys, so welcome back to day three of the Advent of Code. Um, Today's problem is you're in this computer shop and they ask you to deal with some problems. So they've got some memory, which is your puzzle input. So memory is what's in the RAM. So they're essentially giving you um, the data in the RAM, but it's in this instruction set. And the goal of the program, it seems like, is just to multiply some numbers. So they're using this mul function that takes in two inputs, we call them x and y, and it multiplies them together. So 44 and 46 multiply to 2024. However, because the memory's been corrupted, there are also many invalid things that should be ignored, like that's wrong, it's wrong, 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 no spaces, and they should all do nothing. So here's a part of the input. Wow, it really has been corrupted. And we only want to handle the highlighted sections. We want to ignore the text around them. We only want to handle these valid mul instructions. We want to compute them all, and then we want to sum the results. So once you really manage to understand this, it's actually not too difficult to implement in code. So let's take a look at how I implemented it in Rust. So because our data is so much less structured today, my load and pass function has got a lot simpler. What we get out is we just get out a string. We just get out all the data in one big string. And we ignore new lines because it doesn't matter, even though new lines are present in the puzzle input. So blah, 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 we load in the data. Let's get to part one. This challenge requires something called regex. Now, regex means regular expressions, and it's basically a way to find things inside of strings. And it's the reason I'm telling you about this is because it's not just a thing that's present in Rust. It's a thing that you'll use in Python, in JavaScript. I think also in Java. It's very ubiquitous. So let's take a look at what we're actually doing. So I've written some regex here to match the criteria that they said. So this, you can ignore the R thing. That just means it's specific for Rust. It means it's a raw string literal. But we don't need to worry about that. So starting from here, in quotes, this is the regex. This is what the regex is. It's a regular expression here. So what I'm doing is I'm matching. Let's go through it step by step. I'm matching anything that starts with mul. That sounds simple enough. Now, because brackets are part of the syntax of regular expressions, we have to do something called escape them. And that just means we put a backward slash in front of them. So here, we're saying that we want to actually match the bracket. We don't want it to be part of the syntax. We want to match for it. So we put the backward slash there. So now what we're matching is mul open bracket. Now you might be thinking, what do these mean? So this means that I want to match any number where that number has more than one digit. So it means I want to match the number 5, I want to match the number 26, and I want to match the number 527,253. Like, quite a wide range of numbers, like any number, basically. And then I've got a comma. That just means I want that to be a comma between the numbers. No space, because the space has made it invalid. And then I've got another number, and then I close the brackets. I want to match the closing brackets, so I put the backward slash there to escape it. Now, after this, I call the .unwrap function. Now, what the .unwrap function means is that if there's an error, I just want the program to crash. I don't want to handle the error. And that's just me being lazy. As you can see, I've used it quite a lot. But the reason that I can use it safely in this case is because I've written and tested the regex, so I know it's going to work. So I don't need to handle these errors, and you'll see me do that quite a lot. And that's because our data set's very regular. We know that there aren't going to be problems. We know what we're getting. So let's go through it. So we're creating this thing called sum p1. That's sum part 1, and it's a 32-bit integer. Now, we're using our regex by saying regex p1, read p1, and we're saying captures iterator. So what the captures iterator means is that we are just going through our string, and we're finding all the matches. So we're finding every multiplication function, and we're doing that for our data. Now, please ignore the ampersand. That's just something specific to Rust. We're doing that for our data. Now, on this essentially array that we've got, if you like, we're calling the .map function. Now, recall from previous days that the .map function runs some code for each element of the iterator, for each element of the array. And the way that we run code in the .map function is we pass it in what's called an anonymous function, which you've seen in days 1 and 2. So this is like our parameter that goes into the function, and we wrap that in these tool things. I don't know what they're called. And then this is the actual code of our function. We can, if we like, we can wrap it in those curly braces to make it a bit more clear. But because we're doing a one-liner, we don't need to. So what I'm saying is that the first thing that I capture, which is, so the 0th thing that I capture, because array start at 0, is the whole mul function. That would give me the whole thing. So that would say mul, open brackets, 1, comma, 2, close brackets. But cap index 1 is this first thing here, which is what's called a capture group. So this would give me 1 as a string. I pass it into a 32-bit integer. I call .wrap to crash the program if there's an error, because we know there won't be an error because we matched it to this regex, which already handles getting numbers for us. So that's the same as the int function in Python, or it's the same as casting types in Java. So this is now my first number. So for our example, that would be, for the example of mul12, this would be 1. Okay? And then this gets the second capture group here. This is the second capture group, the second number. We pass it into a 32-bit integer and we ignore the error. So in our example, this would be 2. So we're saying 1 times 2. So after this map has run across the array, we're going to end up with a new array. And that array is going to be of all the results of our multiplication function. So it's going to be an array of 32-bit integers. And now on this array here, we're calling the .sum function. And as you can imagine, that function just adds up every element in the array. So this gives us our value for the part 1 data that we needed. Now we don't really need that in there, I think. That just formats things that aren't correctly designed to be printed, and it's useful for if you're debugging in development, but because we can print a number, we don't need to do that. So I hope part 1's making sense. We've taken quite a while. I'm sorry, this is going to be a bit of a longer video because part 2 is pretty complex. But let's go on to part 2 anyway. So as you scan through the corrupted memory, you notice that there are a lot of conditional statements that are still intact. So you can see we got the muls, we got the don'ts, and there is a do function. Ignore that it's part of an undo function because we only care that it says do, open, close brackets. We don't care about what's around it. So what do they care about? The do function enables the mul and the don't function disables the mul instructions. Only the most recent one applies, so we can model this using some state. We can model this with a boolean value that's true if mul is enabled and false if mul is disabled. So do will set the variable to true and don't will set it to false. Sounds pretty simple. And then we just do the same thing that we did before, we calculate the sum. So let's head back to the code. I implemented this in a slightly different way because I'd left my code and then I'd come back to it later on in the day. So we got part 2. We've got some new regex. Let's go through this real quick. So we got the same thing before with our same capture groups here. Okay, and then we have this pipe, which means or. So we're saying we want to match do, open, close brackets. We're escaping the brackets, remember. And then we're saying we also want to match don't, open, close brackets. All right. We've got this sum because we're keeping a rolling sum this time. We can do it with a nice array, but I was pretty tired when I wrote this, so I decided not to. We've got the state that I talked about here, which is a mutable variable, mutable boolean. So we iterate through every capture. We iterate through everything that we've captured. So everything that matches our regex in our data. So we get this array again. And we say that if our capture is a mul, so ignore this is a variable. So we say that if we get something in the first capture group, if we get something here in the first capture group, that means it must be a multiplication function. So then, based on that assumption, we go in and we check if multiplication is enabled, and if it is, we multiply and then we add it onto our rolling sum down here. And then else if, so if it's not a multiplication, then it must be a do or a don't, or it's something else that we don't care about. So if cap.get is the 0th thing, recall that that was the whole thing that we matched. So we go through that and we say that we use the map or function. So we go through the result and we say that we want to convert it to a string, or if it's not, we just want to leave it. So if that is equal to do, then we'll run this code, we'll enable it. And similarly, if it's equal to false, then we won't enable it. And then the loop goes again. And then we end up with our sum. So why don't we just run the code to check if it's working? What did I do? Oh, phew, it worked. Okay. Alright, so that's perfect, guys. Thank you. Now let me just handle a brief bit of admin. Java Club, due to the computing block being used for criminology exams, it will be taking place in M7. So that's Mr. Yap's classroom, and I would like you to get there as promptly as possible. And we'll be implementing day 1, or we'll be implementing day 4, depending on how much time. And we'll be doing that in Java, which will help you with your knowledge for the robotics team. Thank you very much, and I'll see you tomorrow lunchtime in M7. Thank you.